Hello there, and welcome to another Unity tutorial. In this tutorial, we're going to create an AI agent. So this AI is going to be an NPC, a non-player character in our game, and it's going to wander around a defined area. And if the player gets too close, it will start counting down. And if that timer expires, it will detonate and damage the player if they are within the range of the explosion. And if the player leaves the AI's trigger before the timer expires, it will resume its normal behavior if the instance has actually been toggled to do so. Otherwise, it will continue to detonate. Okay, so the first thing I'm going to do is right-click in my hierarchy window, go to 3D Object, and create a new cube. We'll reset the object's transform, and we'll just drag it to sit on the plane, and we'll move it away from some of our other stuff here. Okay, the next thing we'll do is rename the object, so we'll call it MineAgent. And now I want to add some components to this object. So the first component is going to be a second box collider. So we'll move close in to see this. So this second box collider, the first thing we want to make sure we do is turn it into a trigger by turning isTrigger on. And before we go ahead, I'm actually going to resize our cube so that it's half its size. So it'll have a scale of 0.5. I'll move it back down onto the ground plane here. And now we want to change some of the values for our box collider, our trigger collider. So first we'll change the size. So I'm going to set the X value to 3, the Y to 1.5, and the Z to 3. And we can see the second collider is now larger than the cube itself. And this is going to represent the area that the player has to enter in order to trigger the detonation sequence. Now, if we have a look closely, we'll see the collider actually sits below the base of our agent. So now we just want to move this collider up slightly. So for our trigger box collider, I'm going to set the Y position for the center to 0.25. And you'll see that now the bottom of the collider is flush with the base of the cube. Okay, so we need to add one more component to this object. So I'm going to click Add Component, and I'm just going to type in Agent. And we want to add a NavMesh agent to this object. So a NavMesh agent is Unity's inbuilt component that allows the game object to utilize a navigation mesh. And what a navigation mesh is it's kind of like a map of the environment that defines where the AI can and cannot walk. So we'll get to baking a NavMesh in a second, but first I just want to toggle a couple of properties for the NavMesh agent. So first of all, we need to make sure we have a stopping distance. And this is how far from the target destination the agent needs to be in order to start slowing down. So I'm going to set this value to 0.5. So a relatively small stopping distance, which means that the agent will have to get fairly close to its target destination before it can stop. Now for this particular AI, I also want it to move a bit slower. So to change its movement speed, we have this speed value here. So I'm actually going to change this to like 1.5, so fairly slow. Now the other property we just want to make sure is toggled on is auto braking. And when this is toggled on, it means the AI will automatically start stopping when it realizes it's getting close to its target destination. Okay, so we've set up our AI agent for now, and now we need to get to baking a navigation mesh. Okay, so in Unity, a navigation mesh will only account for the objects that are consistent in their position throughout the game. Now, what I mean by that is that game objects that are static are the only game objects that a navigation mesh will be able to be baked on top of. So I'm going to select my ground plane here as an example, because our ground plane never moves, right? It's not animated and it's not programmed to move in any way. So to mark this object as static, I'm going to come over to the inspector with it selected, and on the right of its name, there's a checkbox next to the word static. And I'm going to turn that on, which means this game object can now not be transformed during runtime. Okay, so for this scene, that's all I need to set to static. Now I haven't set any of the triggers to static on purpose, even though they don't actually move during the game. And that's because I want the NavMesh to ignore them, to not account for them. Now actually, I might just demonstrate. I'll turn this one here to static before we bake our navigation mesh, just to demonstrate why I haven't marked any of the triggers as static. Okay, so now I want to bake a navigation mesh. So I'm going to go to Window, then AI, then Navigation to open my navigation panel. And I'm going to go to the Bake tab here. Okay, so now I'm going to go down to Bake and click Bake. And you'll see after that, we have this blue plane on top of our ground plane. And we can see that the area around the trigger that we marked as static has been carved out. So if the blue area in the navigation mesh represents where the AI can walk, that means that they can't actually walk in this spot here. And because this is a trigger, it's not meant to be a physical object, I want the agents to be able to move through them. So I'll just quickly go back to the inspector, unmark that as static, go back to navigation, and you'll notice the navigation mesh is only visible when you are in the navigation tab. And then I'll click Bake, and now my navigation mesh is baked the way I want it. Okay, so if we were to hit play now, nothing would happen. And that's because even though our MineAgent has all of the required components, and it's all been set up correctly, we haven't actually added any functionality to it. So we need to write a script for it. So with the MineAgent selected, I'm going to click Add Component, and I'm going to start typing MineAgent. I'll select New Script. And yes, MineAgent is the name I want to give this script. So I'll click Create and Add. And you can see that's created the script and added it to our game object here. So now we need to open it in Visual Studio. Okay, so I have the MineAgent script open. And as usual, let's start by declaring the variables we'll need. So the first variable we're going to need will be a serialized private variable of the type bounds. And we'll call this bound box. And we'll give this a tooltip. So we'll open a tooltip attribute. And the tooltip we're going to give to this will be defines the area within which the agent can move. Okay, underneath that variable, we're going to have another serialized variable. And it's going to be a private integer. And we'll call it max position samples. And we'll give it a default value of 10. And we'll open a tooltip attribute for this variable as well. And this one will say defines the maximum amount of points that will be sampled for a valid new random position. Okay, so we have one variable that defines the area that the AI can move in. And this variable here is going to be used when we try to find a valid position on the nav mesh to move within. And both of these variables are sort of related to one aspect of the AI compared to the next set of variables we're going to define. So I want to separate them in the inspector, and we can do that using a header attribute. So above both of those variables, I'm going to open another attribute, and it's going to be a header. And we'll say this is going to be the navigation variables. Okay. So underneath that, or underneath those variables, we'll open another header attribute, and we'll say these variables are going to be the behavior variables. And we'll start by defining a serialized private float, and we'll call it idle time and set it to a default value of 1. Now let's open a tooltip attribute for this. And this is going to be, it's going to define the amount of time that the agent will idle for when it reaches its current destination. Okay, so it's going to reach its current destination, wait a bit, and then look for a new destination. Underneath that, we'll open a new serialized private float, and this will be called Detonate time. And we'll give this a default value of 1.5f. And we'll open a tooltip attribute for this. And this is going to define the amount of time that it takes for agent to detonate when the player enters the trigger. All right, now our next serialized variable will also be a private float, and this is going to be called Detonate Radius, and we'll give this a default value of 3. Then we'll open a tooltip attribute for this, and we'll say defines the range from the agent that the player must be within to take damage when the agent detonates. Okay, now the last serialized variable we're going to need is a private boolean, and we'll call this resume behavior and give it a default value of false. Open a tooltip attribute for this variable, and this one's going to say toggles whether or not the agent will stop detonating and resume normal behavior when the player leaves the trigger. Alrighty. Just fix that spelling mistake there. Okay, so that's all the serialized variables we're going to need. We are going to need a few more variables. The first one is going to be a private game manager, and we'll call it manager, which will reference our game manager object in the level. Next, we're going to have a private NavMesh agent, and we'll call it agent. And you can see that it doesn't recognize the NavMesh agent type. That throws an error, and that's because we need to inherit from a new namespace. So at the top of the script, I'm going to say using Unity Engine .ai. So after doing that, you can see the error goes away. Now we're going to need 2 more variables. These ones will be value type variables. So we'll need a private vector3, which we call target position, and we'll give that a default value of vector3.0, which is going to give it a default value of 0 on the X, Y, and Z axis. Then underneath that, we're going to have a private float, which we'll just call timer, and give it a default value of -1. So when the timer is equal to -1, it's not counting. Okay, so now we can start defining some functionality. So first, I'm going to inherit the awake function, and we'll give it a summary and just say awake is called before start. And in the awake function, we need to do 2 things. We need to set references for our 2 reference type variables. So the first thing I'm going to say is manager is equal to find object of type game manager, followed by an empty set of parentheses, and then closing the line. And then underneath that, we'll just say try get component, and then out, followed by our agent variable. So that's going to try and find a NavMesh agent component attached to the same object that this script is attached to. Now that's all we need to do in the awake method. So we'll scroll down to the start, and I'll just turn that into a method summary. Alrighty, now for now, all we're going to do here is write a comment and say move to new random position. And we're going to write a method for that, but we'll do that in just a sec. For now, let's start defining our update functionality. So the first thing that we want to check is we want to make sure that our agent has not been forced to stop. The way this AI is going to work is if the NavMesh agent has been forced to stop, then the AI is going to be detonating. But if it hasn't been forced to stop, then it can actively wander around its bounds. So to check if the agent is stopped, we'll open an if statement. And here we're going to check if agent.isStopped, and we're going to make sure that's equal to false, which means that the agent has not been forced to stop. So like I said, if the agent hasn't been forced to stop, then it's wandering around its bounds. So the next thing we want to check is how close the agent is to its current target destination. So to do that, we'll open another if statement, and we'll say if agent.remaining distance, so the remaining distance to its target destination on the NavMesh, is less than or equal to, and we want to compare this to our agent's stopping distance. So I'll say agent.stopping distance. Now, if that's the case, our agent is close enough to their target destination to start idling and then find a new position. So here we want to check to see if our timer is counting. So we'll say if timer is greater than or equal to 0, which means it's actively counting the idle. First we'll say timer plus equals time.delta time, and that's going to increment our timer slightly. Now underneath that, we want to check to see if our timer is now greater than the idle time, because if it is, that's when we want to find a new position, as well as turn the timer off. So here we'll open another if statement, and we'll say if timer is greater than or equal to idle time. And here we'll turn our timer off because we've stopped idling. We can turn the timer back off and reset it. And underneath that, I'll just write a comment, just like we did in the start, and say move to new random position. Like I said, we're going to create a method for that. Now this if statement here is only going to execute if timer is greater than or equal to 0. And when the timer is off, it's not, it's a negative number. So we want to add an else statement to counter this if statement here. And this is just going to turn timer on. So if the timer is not actively counting and we're close enough to our target, we're going to turn our timer on. And then the next frame, it's going to check to see if the timer is currently on, see that it is, then start incrementing it and comparing it against our idle time. So that will be the idle functionality implemented. But the next thing we want to do is implement our detonate functionality. So I'm going to open an else statement to counter the if statement checking if agent.isStopped is equal to false, which means this else statement will execute if agent.isStopped is equal to true. So if the agent has been forced to stop. So what we want to do here is open an if statement and check if our timer is less than our detonate time. And if it is, we just want to increment our timer. So we'll say timer plus equals time.delta time. And we'll open an else statement to counter that if statement. So this else statement will execute if our timer value is greater than or equal to our detonate time. So if that's the case, well, the agent needs to detonate. So again, here I'm going to say timer is equal to -1 just to turn it off. And then I'm going to write a comment and just say detonate for now, because we're going to write a method for that too. But we'll get to writing those custom methods in just a second. At the moment, you might be asking yourself, at what point does the detonation timer get activated? And when is the agent forced to stop? Well, that stuff will happen when the player enters the trigger collider. So underneath our update method here, I'm going to create a new method, and I'm actually going to inherit the onTriggerEnter method. And we'll write a quick method summary for it. And we'll say onTriggerEnter is called on the frame foreign collider is first detected within this object's collider. Okay, so in the onTriggerEnter method, so the first thing we want to do is we want to check that the object entering this trigger collider is tagged as the player. So we'll open an if statement and we'll check if other.compare tag is equal to true. And the tag we're going to check here is going to be for player with a capital P. So if it is the player entering the tag, we want to do two things. We want to force our agent to stop by saying agent.isStopped is equal to true. And then we want to start our detonation timer, which we can do by saying timer is equal to 0. Okay, so that will start the detonation timer. But what if the player has toggled the AI to resume its behavior when the player leaves the trigger? Well, for this, we want to use the onTriggerExit method. So I'm going to inherit the onTriggerExit method. And we'll write a very quick method summary and say onTriggerExit is called on the frame, a foreign collider leaves this object's collider. Okay, excellent. So inside the onTriggerExit method, what we want to do is open an if statement. And we're going to check two conditions inside this if statement. The first one we want to check is that the resume behavior toggle has been set to true. So we'll say if resume behavior is equal to true, Now to check a second condition at the same time, we need to use two ampersands, which is the C# AND operator. And the second thing we want to check here is that the objects tag is marked as player. So we'll say other.compare tag player is equal to true. So now in order for this if statement to execute, both of those conditions will need to evaluate to true. So if the player leaves the collider and this instance of the agent has been marked to resume its behavior, we're going to say agent.isStopped is equal to false, so it's no longer forced to stop. And then we're going to turn our timer off by saying timer is equal to -1. Okay, so at this stage, we're ready to start writing our first custom method. So this method is going to generate a random point in the bound box and assign it to a variable, which will then be pushed out of the method, and it's going to return a Boolean value based on whether or not it was able to generate a valid random point on the NavMesh. Okay, so it's going to be a private method with a Boolean return type, and we'll call it GetRandomPointInBounds. Now the first parameter is going to use the out keyword. It's going to be of the type vector3, and we'll call it random point. The second parameter is going to be of the type integer, and we'll call it samples. Now that out parameter is going to be a variable that we assign the random point that we generate to that can then be accessed from where the method was called. So first let's generate a new random point. So here we're going to get our out variable random point, and we're going to set it equal to a new vector3. And in the parentheses here, I'm actually going to just push the parentheses to the next line, because this is going to be kind of a large vector to fit on one line. So first of all, we want to get a random point within the extents of our bound box. And we need to do this individually for our X, Y, and Z axes. So first, to generate a random number, we use random.range. And the two parameters I want to pass to this method, the first one will be our minimum, which is going to be negative boundbox dot extents dot x, and then the maximum will be positive boundbox dot extents dot x. So that will generate a random value within the limits of the x-axis for the bound box. Now the next thing we need to pass to our vector3 is the y and the z. So I'm going to do the same thing. So I'm just going to highlight that line, paste it on the next line, then again on the next line, get rid of that final comma. So the last line will be the z-axis. So I'm just going to change x to z, and then the middle line will be the y-axis. So I'm going to go through and change the x to y. Okay, so that's generated a random point within the extents of our bound box, but we actually need to account for where the bound box is positioned. So to do that, we're going to add onto the end of that new vector3 boundbox.center, which determines where it's positioned in the world. Okay, so below that, we'll open an if statement. And here, we're going to check for two conditions. The first one, we're going to check if agent.isOnNavMesh is equal to true, which, as that implies, it's going to check if our agent has actually been placed on a NavMesh. And then we want to check another condition. So again, I'll use two ampersands. And here, I just want to make sure that the extents of our bound box actually has a value. So we'll check if boundbox.extents is not equal to vector3.0. Okay, so the first thing we'll do in this if statement is create a local variable of the type integer, and we'll call it sample count and give it a default value of 0. Now this variable is going to basically track how many samples we've counted and compare them against how many samples we actually want to count. Now next, this is where we want to actually check if the random point is on a NavMesh. So to do this, I'm going to use a while loop. Right, so this loop is going to infinitely keep running until the condition evaluates to false. Now you got to be careful with while loops. If your condition indefinitely evaluates to true, your program will shut down. You'll lock up and go into an infinite loop. And that's one reason we have this sample count variable, is to help prevent that from happening. So firstly, we only want to keep looping while our sample count is less than the amount of samples that we want to take. So here we're going to say while sample count is less than the samples passed to the method. And again, we're going to check a second condition here. So the next thing we want to check is how close our randomly generated point is to a NavMesh to determine whether or not that's a valid position to move to. And there's a method we can use to do this called NavMesh.SamplePosition. And we want to check if the result is false in this case, because we only want to keep looping if the sample was unsuccessful. So here we need to pass in a few variables. The first one is the point that we want to be sampled. So I'll say random point. Now here, if we wanted to, we could use a variable to store the closest NavMesh position. Now in this case, I'm not actually going to do that. So I'm going to say out, and then I'm going to put an underscore, which in C# is the discard operator, which basically just means we're not using this variable. Next is the maximum distance to check from the position that we've passed it for a NavMesh position. Now, according to the Unity documentation for this method, they recommend that you use a max distance parameter of twice the agent's height in order to avoid frame rate issues. So that's what we're going to do. We'll say agent.height multiplied by 2. And then after that, we just need to pass it an area mask. And in this case, we don't want to look for any particular mask. So we just say navmesh.allAreas. Now, if this while loop actually executes, we want it to do two things. The first thing we want it to do is to generate a new random point, which will be tested the next time the while loop iterates. And the second thing is increase the sample count by 1. And in the event that we've reached the max samples, we'll return a failed result. Now, we already get a random point at the top of our method, so I'm just going to copy all of that functionality, go into our while loop and paste it there. So after we've generated a new random point to test, we want to increase our sample count by 1 by saying sample count ++. Then we need to open an if statement and check to see if our sample count is equal to the maximum amount of samples passed to the method. If it is, we need to assign random point a value before we return the method. So we're just going to say random point is equal to the center of our boundbox, boundbox.center. And then we'll return false to stop the method from executing any further. The last thing to do is underneath that larger if statement, we just want to return true if the method manages to reach the end of the code. Now I might just quickly format this bit here. Okay, so that's that method done. But I found it quite helpful to actually draw the points that are being checked in the scene view. So I'm going to write a quick custom method. This is just going to be a private void, and we'll call it drawDebugPoint. And this is going to take a vector3 as the first parameter, which we'll call point. And then it's going to take a color, which we'll just call color, as the second parameter. So what I want this to do is draw sort of like a star in the scene view at a point in a color when we call it. So here, I'm just going to say debug.drawArray, and we're going to pass it point as the first parameter, and that's going to be the point the array starts at. Next, we need a direction. So here, I'm actually going to say 2 multiplied by agent.height, which is the distance that we're checking with the sample position method. And then I'm going to multiply that, starting with vector3.up. Then we'll pass it color as the third parameter. And then we'll just say 2 seconds. We'll say 2f for 2 seconds. The array will last in the scene view. So that's going to draw array upwards from the point that's being checked, but I want to draw it in like all of the directions. So I'm going to duplicate this 5 more times. 1, 2, 3, 4, 5. So we have 6 in total now. And the only thing I need to go through and change is the direction. So for the second line, I'm just going to put a minus in front of vector3.up, which is going to draw the ray down. So that'll have a ray going up and a ray going down. Then for the third line, I'm going to change up to right. And the fourth line will also be right, but will have a minus in front of it. So that's going to draw a ray right from the point and left from the point. And then lastly, we'll have forward for the fifth line and for the sixth line, with the sixth line also having a minus in front of it. So now let's actually just go back up to our GetRandomPointInBounds. And at the top of our while loop, inside our while loop, let's call our draw debug point. And here we're going to pass it random point. And the second parameter, we're going to pass it color.red, because in this event, the point that's been checked by sample position has not found a valid NavMesh point. So we're going to draw that point in red before we generate a new random point. Now, immediately underneath the while loop, I'm also going to call draw debug point. Again, I'm going to pass it random point as the first parameter, but color.green as the second parameter. And that's because if the method manages to get to this point, it means that this hasn't executed, this return line here hasn't executed, which means that we've found a valid point here. Okay, excellent. So above the GetRandomPointInBounds method, we're going to declare a new method, which is going to be a private void, and we'll call it move to new position, and it won't take any parameters. Now here we're actually going to utilize our GetRandomPointInBounds function, and so we'll say if GetRandomPointInBounds, and we'll say out, and we'll pass it our target position variable as the one to assign the random point to, and we'll pass max position samples as the amount of samples to take to find a path, a valid point. And we'll check if that's equal to true. And if that is equal to true, it means we were able to get a valid random position. So we'll say agent.setDestination and pass it our target position variable, which will actually move our agent to that destination. Okay, so now we have a way of moving our agent to a random point. Let's go up and replace the comments, the two comments. So one in the start, we're going to replace that with a call to move to new position. And then the same for the comment in the update that says move to new random position, we'll replace with a call to move to new position. Next, we'll create our detonate function. So right at the bottom of our script, I'm going to start by making this one public, and it's going to have a void return type, and we'll call it detonate with no parameters. So we'll start by creating a local variable, which will be of the type collider, and it's also going to be an array. So we follow the data type with a set of square brackets, and we'll call this detected colliders, and we're going to set the value to the return value of Physics.OverlapSphere. Now that we need to pass two parameters to overlap sphere. The first is the position that the sphere should be checking from, the origin point for the sphere. That's going to act as like this collider. So we'll say transform.position, because we just want the sphere to be around the agent. So we'll pass the agent's position. And after that, we need the radius for the sphere. So we'll pass detonate radius as the radius here. Next, we'll open a for each loop. And here we're going to check for every collider, which we'll just call collider. In our detected colliders array, here we want to check if the collider that we're currently iterating through is tagged as the player. So we'll say if collider.compareTag equal to true, and the tag we're checking for here is player with a capital P. So if it is the player, then we want to actually subtract a life from them because they're caught within our explosion radius. So we'll say manager.subtractLife, which will subtract a life from the player. Then we can call the break keyword in order to stop the for each loop from further iterating, because there's no need to. We've already damaged the player. Then underneath that for each loop, all we want to do is say GameObject.setActive, and then false is the parameter, which will turn this object off. So with that done, let's scroll back up to our update function and replace the comment here with a call to our Detonate method. Okay, so the last thing we need to do is actually draw our bound box within the scene so we can see it when we're setting it all up. So underneath my onTriggerExit method, I'm going to inherit a private void called onDrawGizmosSelected. So in here, we can actually draw some basic shapes that are only visible in the scene view. So first we'll start off by setting the color for these gizmos by saying gizmos.color is equal to color dot, and I'm going to go with magenta. And then once we've set those colors, we can actually draw the gizmos. And I want to draw two here. First one, I'm going to say gizmos.draw wire sphere, and we'll pass it our target position as the position to draw the sphere at, and then the radius for the sphere, I'm just going to say 0.2 to give it a fairly small radius. Then underneath that, we'll say gizmos.draw wire cube, and here we're going to pass it our boundbox.center as the position to draw the cube at. And then for the size, we'll say boundbox.size to give it the size of the cube. So with all that done, all we need to do now is save the script by pressing Control S and then go back into Unity and set up our agent. Okay, so I'm back in Unity now. So I'm going to select my MineAgent in the hierarchy, and I'm going to scroll down in the inspector down to the MineAgent component. And we'll start by giving it a bound box. So I'm going to give it a bound box of 3 on the X, 1 on the Y, and we'll go 2 on the Z so we get a rectangle. And you can see that's drawn a rectangle in the scene view now. So if we go below the ground plane though, you'll see that the bound box is below the surface of the ground. So how do we raise it up? Well, we come over to the bound box center value, and for the Y, I'm just going to put 1 in, and you'll see that it now doesn't go below and sits nicely on the ground plane. So let's move it over to our agent. So let's just move the center, we'll say -8 for the X, and then for the Z, we'll push it up, we'll say 7. Okay, so now you can see our agent is surrounded by his bound box. And now I'm just going to select my MineAgent and press Control D to duplicate him in the hierarchy. And now I'm going to go to the MineAgent for the duplicate, and I'm just going to turn resume behavior on. The next thing I'll do is I'll just move the duplicate, move him away, and we'll set the center to -7. We'll just adjust it so that it sits nicely. We'll say -10 for the X for this one. There we go. So our agent is nicely in its bound box. So now we can test it out. Let's hit play. Alrighty, so I'm in testing it out now. We're in play mode. So let's go over to this guy on the left first. So if we get close and back away. Oh, I didn't get close enough. There we go. Get close enough and see it gets destroyed. If we come over to this one, do the same thing though. So it'll stop and start detonating, but if we move away, it will resume its normal behavior. But if we stay for too long, it takes a life away from us, which the other one would have as well. Okay, so one thing I want to quickly demonstrate is how our agent samples random positions in the bounds until it's able to find one that's actually on the NavMesh. So to demonstrate this, what I'm going to do is I'm going to come over to the center here, and actually the extents first. We'll set it to 5. I'll set the center to 5. So we've got this much larger area, and you can see it working already. All these red points are random points that have been generated in the bounds, but are not on a NavMesh. And you'll see the green ones are the ones that the agent moved towards, and they are actually intersecting with the NavMesh. So, you know, we could increase the size. We could say, you know, we're like 5 this way, we're like 5 that way. Let's say something outrageously high, like 20, right? So we've got this really large kind of area, and it'll obviously have a harder time finding points, the less samples that we have. So we could say increase this to help with that. And while it can't find the points, you can see like just now, it'll just sit there and sample and sample and sample until it's able to find the points. So we could, increase this to like 50. And what that's going to do is it's going to make it, there's going to be a lot more points, which will increase the chances of a random point being generated that intersects with a NavMesh. Oh, and I've just noticed a bug with our timer text there that we'll have to fix in a later video. So that's it for this video. I hope you enjoyed it and found it useful. If you did, please leave a like. And if you want to see more game development tutorials and content like this, then please hit that subscribe button. Hope you enjoy the rest of your day or evening, and thank you for watching.